My dear students, today I am going to discuss geometry for class 9, the chapter of lines and angles. Yesterday I uploaded one video, so partly from this chapter. Now I did up to theorem 3. So today's discussion will be continuation from yesterday's. Okay. Now today I am going to start from theorem 4. Now this theorem says this: if a transversal cuts two parallel lines, then the co-interior angles are supplementary. Supplementary means sum of the co-interior angles 180 degree. All right. Now in this question, what is given? You see, transversal and two parallel lines given. Now these are the two parallel lines, AB and CD, and PQ is the transversal. So PQ cuts AB at L and CD at M. So all these things are given. And what you have to prove? So you have to prove what? So you have to prove co-interior angles are supplementary. That means this plus this 180 degree. Now these two are co-interior angles. So yesterday I explained in my video all these things. So this plus this 180 degree supplementary, that is what you have to prove, right? Now first of all, given. So what is given here? AB and CD are parallel. So AB parallel to CD, that is given, and PQ is transversal. PQ is transversal. So parallel given and transversal given. Now what you have to prove? So this is how you are supposed to write in exam. First of all, what is given, and then what to prove. Now what is given and what to prove, these things are found in the question. So read the question carefully and then write. So what to prove here? ALM, this angle plus this angle, ALM plus LMC, LMC. So these two angles, which two angles? ALM and LMC. So these two angles together 180 degree, that is what you have to prove. So supplementary means what? If sum of two angles 180 degree, they are called supplementary. So you have to prove the co-interior angles are supplementary. That means you have to prove the sum of the co-interior angles ALM and LMC is 180 degree. All right. Now the proof. Okay. Now see, in a previous theorem, we proved when two parallel lines are intersected by transversal, alternate angles are equal. So in this case, this angle is equal to this angle. That means ALM equal to LMD. This point is M. All right. So this point is M. So according to that theorem, so since AB parallel CD and PQ is transversal, so since AB parallel CD and PQ is transversal, then alternate angles are equal, that is ALM. So ALM, this angle is equal to what? LMD. LMD. Now what reason? They are alternate angles. So since these two are parallel and PQ is a transversal, cutting them at L and M, so these two angles are equal. These two are equal. ALM equal to LMD. What is the reason? Alternate angles. For every statement in the proof, you have to give reason if they are not obvious. Again, we know sum of these two angles 180 degree because they are linear pair. Sum of this plus this and this together also 180 degree because they are linear pair. Again, LMC, this angle plus LMD equal to 180 degree. Again, LMC, this angle plus LMD, these two 180 degree. So what reason here? Linear pair. So these two are equal because they are alternate angles, and these two are yes, these two are equal, they are alternate angles, and sum of these two 180-degree linear pair. All right. Now you see, now this LMD, you can replace, in place of LMD, what you can write? ALM. So this implies LMC plus yes. Now see, in place of LMD, what you can write? ALM, because they are equal. ALM equal to 180 degree. So these two are equal because they are alternate, and again this plus this 180 degree because they are linear pair. Now in this statement, in place of LMD, what you can write? ALM. That is what we are doing. So next line, LMC plus, in place of this we are writing ALM equal to 180 degree. So proved. You see, this was what to be proved. So what to prove? To prove ALM plus LMC. To prove ALM plus LMC 180 degree. So we have done it. All right. So this is how you have to proceed to prove theorem or rider. Riders are those questions which are similar to theorem. You have to prove in the same manner. So this was theorem 4. Okay. Now let us go to next theorem, theorem 5. In geometry, if you are not particular in writing, not systematic and all, marks are deducted. Therefore, be careful in writing the proofs, drawing the diagram properly, because there is a lot of scope in geometry for deducting marks. That is what teachers do. All right. Okay, now theorem 5. Now theorem 5 is converse of theorem 4. Now in theorem 4, what was given? Two parallel lines were given, and you had to prove co-interior angles are supplementary. Now in theorem 5, what is given? Co-interior angles are supplementary, and you have to prove the lines are parallel. All right. So now since theorem 5 is converse of theorem 4, diagram will be same. So that same diagram we can use. So this was the diagram. So AB and CD. All right. Then P, Q, this is L, this is M. So two converse theorems have the same diagram. Okay. Now in this theorem, what is given? The co-interior angles are supplementary. That means the sum of the co-interior angles 180 degrees. So here what is given? What is given? This angle plus this angle 180 degree. That is ALM plus LMC equal to 180 degree. This is given. And what to prove? What to prove? To prove AB parallel CD. AB parallel to CD. So in this theorem, it is given these two angles together 180 degree. Sum of co-interior angles 180 degree. And you have to prove AB parallel to CD. Okay. All right. Now this is what we do the proof. This is how we do it. Now ALM plus LMC equal to 180 degree. So we start from here. Since ALM plus LMC equal to 180 degree. So what reason? This is given. This is given. ALM plus LMC 180 degree, it is given. All right. Again we know these two together 180 because they are linear pair. Again LMC plus LMD that is equal to 180 degree. Reason? Linear pair. So this plus this 180 degree, that is given. And also we know these two together, this plus this 180 degree. Why? Linear pair, isn't it? Now you see, so this is 180 degree, this is 180 degree. So right hand side is equal, therefore left hand side must be equal. Therefore this plus this equal to this plus this. Therefore what we conclude, ALM plus LMC is equal to LMC plus LMD. LMC plus LMD. So this angle plus this angle 180 degree, again this angle plus this angle 180 degree, so 180 degree, 180 degree same. Therefore this part must be same as this. So this part must be equal to this. That is what we are writing. Now these two you can cancel, LMC you can cancel, the rule of equation, same thing from both sides. So what we are left with? We are left with ALM. ALM is equal to what? LMD. LMD. Alright? ALM equal to LMD. That means ALM, this angle equal to this angle we have proved. We have proved these two angles are equal. But these two are what? Alternate angles. Since they are alternate angles, these two lines must be parallel. So that was a theorem we did yesterday. If alternate angles are equal, then lines are parallel, or if corresponding angles are equal, then lines are parallel. Now we have proved here alternate angles are equal. This equal to this. So here you have to write, but these two are what? These two angles are alternate. So we have proved this equal to this, but these two angles are alternate. Therefore, what we conclude? Therefore, what we conclude? AB parallel to CD. AB parallel to CD. According to one theorem before. So if alternate angles are equal, then lines are parallel. Okay. So this is how we do theorem 5. Okay, now we go to theorem 6. So today we will finish up to theorem 8. There are 8 theorems in your CBSE textbook and CRT textbook. Okay. All right. Now theorem 6. Theorem 6. What does it say? Theorem 6. So theorem 6 says lines which are parallel to the same line are parallel. Lines which are parallel to the same line, must be parallel, are parallel. So this is the statement of that theorem. Lines which are parallel to the same line are parallel. So this you have to prove. Prove it. Okay. Now, yes, so what is given and what to prove? So I think you have already understood. So what is given here? Two lines are given which are parallel to a third line. So there are 3 lines in this question. There are 3 lines in this question. So 2 lines, here we take 2 lines and then a third line, same line. So this parallel to this and this parallel to this. So what is given? AB parallel to PQ and also CD parallel to PQ. AB parallel to PQ given and also CD parallel to PQ. And what you have to prove? You have to prove that these 2 lines are parallel. That means AB parallel to CD. So AB parallel to this and CD parallel to this, same line. So we have to prove these 2 parallel. Why they are parallel? Because they are parallel to the same line. That is what we have to prove. Now what is given? What is given? AB parallel PQ and CD also parallel PQ. This is given. So we have to prove what? To prove what? AB parallel CD. We have to prove AB parallel CD. Okay. Now we draw a transversal. So we draw a transversal. So this you can say construction. Alright. So this one we can say construction. So in some question you have to do some construction to help you give the proof. So this is one example where we are doing this construction. Suppose LM. We are drawing LM which cuts the three lines. That means LM is a transversal of these three lines. So that is the construction. So what is the construction? LM is drawn. LM is drawn to cut, to intersect AB, PQ and CD. So we have drawn this transversal. Suppose it cuts AB at X, PQ at Y and CD at Z. So this transversal we have constructed, we have drawn to cut AB at X, PQ at Y and CD at Z. Alright, that is the construction. Now the proof. So AB parallel PQ given. Therefore what? These alternate angles will be equal, isn't it? So since AB parallel PQ, AB parallel PQ what given? AB parallel PQ and LM is transversal and LM is transversal. LM is transversal. Therefore what? According to a theorem we discussed yesterday, so these two must be equal. Why? Because they are alternate angles. Which two are equal? AXY. So angle AXY must be equal to what? Angle XYQ. Angle XYQ. Angle XYQ. What reason? Alternate angles. They are alternate angles. So since these two are parallel and this is LM is a transversal, two parallel transversal, therefore these two must be equal because they are alternate angles. Okay. Now suppose we call it equation 1. Sometimes you have to mark this way. Okay, then next we take the other pair of parallel lines. Again these two are parallel, that is CD parallel to PQ. Again CD parallel to PQ and LM is transversal. LM is transversal. Therefore, so this CD and PQ parallel and this is transversal. Therefore, these two are equal. Why? Corresponding angle. So therefore, angle this one is what? XYQ. So XYQ is equal to what? YZD. Reason what? Corresponding angles. So this equal to this alternate angle. Alright. Now these two are parallel, this is transversal, therefore this equal to this corresponding angle. Okay. Suppose we call it equation 2. Alright. So this is equation 2. Okay. Now compare 1 and 2. XYQ equal to YZD and AXY equal to XYQ. So you see this is XYQ, this is XYQ. So XYQ equal to this and XYQ equal to this. Therefore this equal to this. Therefore comparing 1 and 2 we get. Therefore comparing 1 and 2 or from 1 and 2. That is how you write in exam. From 1 and 2 we get, or comparing 1 and 2 we get. From 1 and 2 we get what? We get YZD. YZD equal to XYQ. So we get XYQ equal to XYQ. XYQ, this one, XYQ, AXY, sorry. So AXY equal to XYQ and YZD equal to XYQ. Therefore, AXY equal to YZ. We get AXY equal to what? YZD. y, z, d. That means AXY this angle. So this angle equal to this angle. So now you forget this part. Just forget this line. Try to concentrate on these two. So what we have got, these two angles equal, see, AXY, this one. This angle is equal to YZD, this angle. Now are not they alternate angle? So these two are straight lines, this is transversal, and we have proved alternate angles equal. We have proved alternate angles equal. Therefore, these two lines must be parallel. So last of all, what we conclude? Therefore, what is the conclusion? Therefore, AB. But here you have to write one thing. But these are alternate angles. That sentence is necessary. This equal to this we have proved. But these two are what? These two are alternate angles. Alternate angles. So we have proved alternate angles are equal. Therefore, we conclude those two lines are parallel. That is AB parallel to what? CD. And that was what we had to prove. We had to prove AB parallel to CD. So got it. Okay. This is how you have to write systematically. So this was theorem 6. Theorem 6. This was theorem 6. Now next we go to theorem 7. Theorem 7 is the most important. So in your exam, theorem 6 that we are going to do is theorem 7. You are likely to get. So in class 9, first exam always includes this. Okay. Okay, now theorem 7. You see these theorem numbers 1, 2, 3, 4, etc. They are meaningless. In different books, different authors give different number. But in your textbook, I am following in your textbook. In your textbook, these numbers are given. That is why I am saying this. Otherwise, if you see another book, another textbook or another reference book, you will see these numbers are different. That doesn't matter, okay? What matters is the theorem and the proof. Okay, now theorem 7. Theorem 7, this is called angle sum property. This theorem is called angle sum property. Angle sum theorem. Angle sum property. Angle sum property of triangle. So this theorem is known as angle sum property of triangle. That means it says sum of all the triangles of a triangle 180 degree. So that is a statement of the theorem. Sum of the three angles of a triangle, any triangle of a triangle is equal to 180 degree. This is the statement of that theorem. So this theorem says sum of all the three angles of a triangle is 180 degree. And this is what we are going to prove. So we have to prove this thing. Sum of all the three angles of a triangle is 180 degree. Okay. All right. Now, so this we are going to prove. So let us draw a triangle. So this is a triangle. Suppose let us call it ABC. ABC is a triangle. This triangle is given. This triangle is given. So what is given? Triangle ABC. So ABC is a triangle. So what is given? ABC is a triangle. ABC is a triangle. That is what is given. And what to prove? To prove, yes, A plus B plus C equal to 180 degree. To prove angle A plus angle B plus angle C equal to 180 degree. So ABC is a triangle that is given, and we have to prove sum of these three angles A plus B plus C equal to 180 degree. Okay. Now here also we need to do some construction work. We have to do some construction to help us get the proof. Now what construction we do? We draw a straight line through A parallel to BC. Suppose we draw PQ. We draw PQ through A parallel to BC. So that is what we must write. Construction is what? PQ is drawn through A, through the point A, through through A parallel to what? BC. So what construction we do? PQ is drawn. PQ is drawn through the point A parallel to BC. So this PQ is parallel to BC according to construction. Now we come to the proof. All right. Now see, PQ is drawn parallel to BC, PQ parallel to BC, and this is a transversal. Therefore, this angle is equal to this angle, alternate angle. So PQ parallel to BC and this line cuts them. All right. Therefore, so PQ parallel to BC and this line cuts them. Therefore, these two angles are equal. Why? They are alternate. Again, PQ parallel to BC and this cuts them. Again, in the next diagram, these two and this is the transversal. This is the transversal. Therefore, this angle equal to this angle. That means this angle equal to this angle. So this equal to this alternate, this equal to this alternate. That is what we are going to write. Okay. All right. So since PQ parallel to BC and AB is transversal, AB is the transversal. Therefore, angle PAB is equal to angle ABC, angle B. So why? They are alternate angles. So PAB equal to angle B. Now you see, we are using only one letter because at this point B there are no other angle, only one angle is there. When there is only one angle at one vertex, you can use one letter. But here we cannot use one letter. We have to use all the three letters because there are so many angles here. Okay, fellow? Okay, that is equal to angle B. Next, again, PQ parallel to BC. And this time we take AC as the transversal. All right, AC is the transversal. Therefore, which two angles will be equal? QAC is equal to what? Angle C. What reason? Alternate angles. So this equal to this alternate angle, this equal to this alternate angles. All right. Okay. Now, yes. Now what we have to prove? We have to prove this angle plus this angle plus this angle 180 degree. So now angle A. Now this time let us not write angle A. Let us write the full name BAC because at the point A there are so many angles. So angle BAC, therefore angle BAC plus angle B is ABC. Let us write now these three letters because here we use three letters. Then angle C, that is ACB. Therefore this plus this plus this we can write equal to what? You can write equal to, yes, now in place of BAC, now BAC remains as it is. We are going to replace the other two. So BAC as it is. In place of ABC, what we are going to write? PAB. Plus, now in place of ACB, what we are going to write? QAC. So this angle plus this angle plus this angle is equal to this angle as it is. In place of ABC, we are writing PAB because they are equal. In place of ACB, we are writing QAC because they are equal. Okay. Now continue simplifying. So BAC, PAB, BAC. Now you see, yes. Now look here. BAC is this angle. PAB is this angle. And then QAC is this angle. So this angle plus this angle plus this angle. This BAC is this angle, PAB is this angle, and QAC is this angle. That means this angle. So these three together, which angle? This angle. And this angle is 180 degree because it is a straight angle. So these three together, what we get? 180 degree region. Okay, so suppose first of all let us name the angle. So these three together is which angle? Angle PAQ. Angle PAQ. So this plus this plus this, these three together we get this angle PAQ, and this is a straight angle PAQ, and that is equal to 180 degree region straight angle. So straight angle is 180 degree. So what we have got, sum of three angles of a triangle equal to 180 degree. This is the proof. There is another way of proving it. There are actually two more ways to prove it. Now whichever way you like, you do. In the reference book, if you see, you may find two other ways, but this is one of the easiest ways. All right. Okay, so that was theorem. So as I told you, this is very important, very common in exam. Okay, now the last theorem, theorem 8. So now we come to theorem 8. So again, let me say theorem 7 is the most important out of all this. So theorem 8. Theorem 8. Now this theorem says external angle of a triangle is equal to sum of the opposite internal angles. So this is a statement of this theorem. External angle of a triangle is equal to sum of the opposite internal angles. Now see, this is the diagram. So this is how the diagram comes out. Now this is a triangle. This is a triangle ABC. Now external angle, how will you get external angle? You will get when you produce any side. Suppose we produce BC, BC to suppose D, then this angle is the external angle. If you produce AB this side, then this will be external angle. So if you produce any side, then you will get an external angle. So external angle of this triangle, so let us say this external angle ACD, that is equal to sum of A and B. A and B are internal angles and they are opposite, not this one. This is also internal. So there are three internal angles, this one, this one, this one. But here what is mentioned? These two, opposite. So here what we have to prove? This angle equal to sum of these two. So what is given? Given ABC is a triangle and ACD is the, so that is what given. So what is given here? So you have understood, I think. Given is ABC is a triangle and ACD is the external angle. And to prove what? To prove this angle ACD, this angle is equal to, sum of these two, angle A plus angle B. All right. So this is external angle. To prove this external angle is equal to sum of the opposite internal angles. This equal to this plus this opposite internal angle. Okay. Yes, the proof is very simple. So see this way. Now how the proof comes? Proof. Now, yes, that angle sum property, using the angle sum property, we write angle A plus angle B plus angle C. So this plus this plus this. Now this one is ACB. So that is equal to 180 degree. Why 180 degree? Angle sum property. So angle sum property. So in the exam you write fully angle sum property. So in this triangle, sum of these three angles 180 degree. Okay. Again this plus this 180 degree, linear pair. Again angle C. Angle C means this angle C plus ACD. Again this plus this equal to 180 degree. What reason? Linear pair. So this plus this 180 degree using angle sum property, and this plus this 180 degree because linear pair. Now you see 180 degree same, therefore this must be equal to this. Therefore ABC, A plus B plus C, these three angles, this plus this plus this must be equal to this, must be equal to what? Angle C plus angle ACD. Because this is equal to 180, this is equal to 180, obviously this equal to this, A plus B plus C equal to C plus this. Now equation rule, cancel C from both sides. Therefore what we are left with? A plus B equal to ACD. A plus B, what we are left with? A plus B, angle A plus angle B equal to what? Angle ACD. And that is what we had to prove. You see, to prove what? You see, ACD equal to A plus B. So ACD equal to A plus B. Proved. I followed. So this angle is equal to this. Now from here one important result follows. External angle is greater than the opposite internal angle. This angle is equal to this plus this. Therefore this angle must be equal, greater than this and greater than this. So this is the sum of these two. This is the sum of these two. Therefore this is greater than A, this is greater than B. That is another important result which you will have to use in some numerical problems. Okay. All right. So today we finish all the theorem. Then I'll continue and I'll show you in my next video some riders. Riders are questions which you have to prove just like theorems. There are many of them, but I'll show you a few in my next video. Okay then, so we'll stop for today. Okay, thank you.